Welcome back to this channel. This video we are going to start with 4.2 molecular shape and polarity. However, in this video basically we only focus on the molecular shape, which means that we are going to focus on valence shell electron pair repulsion, draw the basic shape and also predict the shape and also the bond angle. Let's start with this theory, VSEPR theory, which actually is used for us to predict the molecular geometry. So according to this theory, they will say that electron pair or electron domain are going to repel each other at where they are trying to arrange themselves as far as possible. This is the first point in this theory. Second point in this theory, let us know that the repulsion between the lone pair and lone pair is the lone pair and lone pair electron is the strongest, followed by lone pair bonding pair and bonding pair electron is the weakest. Okay, so these are the also the question asking in the tutorial question number 1A. So actually how we going to determine the molecular geometry? First you must draw the Lewis structure. Based on the Lewis structure, you are going to determine the electron domains. Okay. Basically, we need to know there's how many bonding pair and also how many lone pair electrons. So reminder again, one electron domain can be represent one single electron or one lone pair electron or one single bond or one double bond or one triple bond. All these are considered as one electron domain. After we determine the number of electron domain, then we are going to base on the number of electron domain to get the basic shape. After based on the basic shape, then only we can able to determine the molecular geometry. Before go in details, let's check. These are the 5 basic shapes that we need to know. First is the linear, at where the bond angle is 180, followed by trigonal planar with the bond angle 120. Next is the tetrahedral with 4 terminal atoms, bond angle 109.5, followed by 5 electron domain, trigonal bipyramidal with 2 bond angle. At the side here is 120 and here is 90 degree. And then the last one is octahedral, at where we will have 6 electron domain. Each bond angle is 90 degree. You can see this shape more obviously if you tie the balloon together. If you tie 2 balloons together, it will automatically arrange themselves in linear shape and so on for others. Besides to know the molecular shape, linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral, don't forget we also need to remember the bond angle. However, if you're able to draw the molecular shape, I believe that there is no problem in identifying the bond angle. So only need to remark here, for the trigonal bipyramidal, there is 2 bond angle. So if there is any lone pair electron, we will place the lone pair electron at the side with the 120 degree because we know that lone pair electron need more space. While for others, you can place the lone pair electron at any place that you wish to for the first time. Now, let's proceed to tutorial question 1B. For the following molecule, draw the Lewis structure and deduce the molecular geometry. Okay, so we consider that every of you already know how to draw the Lewis structure. So we continue with the step number 2. This is step number 1. Draw the Lewis structure. Step number 2, if you still remember, we need to calculate the number of electron domain. So we focus on the boron central atom. There are 3 single bond, means that there is 3 electron domain. So if this is the 3 electron domain, so step number 3, the basic shape is trigonal planar. And then step number 4, because there is no lone pair electron, so the electron domain, the electron arrangement will similar with the molecular geometry, which is also trigonal planar. Okay, and then the Lewis structure is already drawn in the shape of trigonal planar. So second question, CLF3. After we draw this Lewis structure, again focus on the central atom. We have 3 bonding pair plus 2 lone pair electron. So the total electron domain is 5 electron domain. So the basic shape is trigonal bipyramidal. Okay. So again, in this question number 2 here, there is 2 lone pair electron. So according to the second point in the VSEPR theory, we are going to make sure the lone pair electron have more space. So this is the structure for the trigonal bipyramidal. Okay, and then the bond angle here is 90 degrees, while at here is 120. Again, because of lone pair electron need more space, there is 2 lone pair electrons, so we are going to remove 2 terminal atoms at here. So end up we get this shape. So this shape is similar with T, so we are going to call this one as T shape. Yes, let's continue with the third question, SDFE. So again, focus on the central atom. There are 3 lone pair plus 2 single bonds. So again, total 5 electron domain. Yes, the basic shape is still trigonal bipyramidal. So again, we are going to imagine there is 5 electron domain. Let's say now we have, for example, just now we already have 2 electron domain, 2 lone pair electron. So the shape is T shape. So now we have 1 more lone pair electron. So this time the lone pair electron we will place at the right hand side here, so that the electron is arranged themselves as far as possible, and then the lone pair electron need more space. So with this, now the shape is linear. So molecular geometry is linear. Question number 4, NH3. This is the Lewis structure of the NH3, which when we look at here, there is 4 electron domain, 3 single bond and 1 lone pair, so 4 electron domain. So the basic shape is known as tetrahedral. Okay, so if we roughly draw like this, this is the shape for the tetrahedral. So if you will have 1 lone pair here, imagine that you remove 1 terminal atom. So now this is the shape. This shape we will known as trigonal pyramidal. Okay. Now we continue with the question number 5, ICl2+. So again, focus on the central atom. This central atom again have 4 electron domain, tetrahedral as well. So it will look like this. And then, but this time we have 2 lone pair electron. So first lone pair electron will be removed from here. We will place the lone pair electron here. Second lone pair electron will place at this position. So end up we can see the shape is like V shape. So we also can note it as V shape, or we also can note it as bag. Last question, CH4, very obvious also. The central atom carbon consists of 4 electron domain. So the basic shape is tetrahedral. At the same time, there is no lone pair electron. So all these 4 bonding electrons will still arrange themselves as in tetrahedral shape. Let's continue with tutorial question number 2. We need to draw the Lewis structure for ClO3- and also ClO4-. Then we are going to state the molecular geometry and predict the bond angle. So even though sometimes when we draw the Lewis structure, we will draw them in 2D dimension. So for example, ClO3 negative, even though throw it in 2D dimensional, but again, when we want to determine the geometry, please focus on the central atom. In this case, we have noticed that there is 4 electron domain. So the basic shape will be tetrahedral. So we can roughly draw out the shape of the tetrahedral. Then, because there is one lone pair, so we can place this lone pair electron at anywhere. So to make it easier for us to predict the coming shape, so we imagine the lone pair electron placed at the top here. So end up, we will get the molecular geometry known as trigonal pyramidal. Continue with the next question. ClO4 negative. At where this time we notice again on the central atom. This central atom also shows there is 4 electron domain. And then again the basic shape still the tetrahedral. No matter there is how many lone pair or how many bonding electron, as long as the electron domain is 4, means that they are going to have similar basic shape. However, this time for the chlorine, there is no lone pair electron. Therefore, the molecular geometry will be similar with the basic shape. Okay, so we already done for the part of molecular geometry. Now we're going to enter the part of bond angles. Okay, as we already know that for tetrahedral, basically the bond angle is 109.5 degree. But because here we have one lone pair electron, and then we know that lone pair electron need more space and also repel stronger, which will make the bond angle over here, because they will push the repel down here, so cause the bond angle here become smaller. But what is the exactly bond angle? We have no idea, because different atom will, or different element, they will repel with different strength. But generally, we know that there will be have repulsion here. So when we want to determine, mention the bond angle, we cannot still maintain as 109.5, but we are going to list down here less than 109.5. For Cl4 negative, because the bond angle is 109.5 for tetrahedral, and during the molecular geometry, there is no lone pair, so this bond angle will be remain. Okay, in this slide, we are going to focus on the second main point in the VSEPR theory, where we are emphasized on the type of repulsion forces. There are 3 types. One is between bonding pair and bonding pair electron, between lone pair and lone pair electron, and also between bonding and lone pair electron. So as we already get some idea in the earlier part, so mentioned that lone pair electron occupy more space because their repulsion is more stronger. Okay, because of this, then the molecular shape and also the bond angle will be different from the basic molecular shape. Okay, so the strongest repulsion is between lone pair electron with lone pair electron. Let's continue with tutorial question number 6a. According to the VSEPR theory, you have to describe the methane, ammonia, and also water. So before we can explain detail based on the VSEPR theory to predict the bond angle and also the molecular geometry. So as usual, step number 1, we have to get the total number of valence electron. At this question, all the 3 methane, ammonia, and also water has 8 valence electron. So based on the valence electron, then we can draw the Lewis structure. So after we draw the Lewis structure, then we can get the electron domain, the arrangement for the electron domain or the basic shape. Okay. So because all these 3 central atom, carbon, nitrogen, and oxygen, have 4 electron domain, so the basic shape is tetrahedral for all of them. But because there is a lone pair electron in certain molecule, so their molecular shape will be different. Okay. Tetrahedral is the basic shape for methane, and also for the molecular shape also still the same, tetrahedral. However, for the ammonia, because there is one lone pair electron, so that's why the shape of the molecule will become trigonal pyramidal. While water has two lone pair electron, so that's why the shape is known as V shape, or we can also know as band. So now, if we based on the number of lone pair electron and bonding pair, so for the methane, all are bonding pair. So the type of repulsion between them is always bonding pair and bonding pair repulsion. For the ammonia, there is 3 bonding pair and 1 lone pair electron. And where we here and here we have the repulsion between bonding and lone pair electron. While for the water, there is 2 lone pair electron and 2 bonding pair. So the repulsion will be in between lone pair and lone pair electron. Okay, because of the lone pair electron need more space, so that's why you can see the bond angle at where if there is no lone pair electron, the bond angle is 109.5. With one lone pair electron, the bond angle will be switched to 107, but this one is specific for the ammonia. If let's say it is trigonal pyramidal, but it is not ammonia, the bond angle not necessarily equal to 107, but what we can confirm is smaller than 109.5. Okay, and then we use another concrete example, which is the water consists of 2 lone pair electrons. So once 2 lone pair electron means that lone pair electron need more spaces compared to ammonia, because during the ammonia we only have 1 bonding and 1 lone pair. So when we have 2 lone pair electron, the type of repulsion is lone pair and lone pair electron. So again, the bond angle will become smaller if compared to ammonia. So end up, when we have the bond angle comparison, methane has the biggest bond angle, while water have the smallest bond angle. Okay, this is the final answer for objective question, tutorial 4.1, and also the tutorial question for 4.2, which we already went through just now, question number 1, question number 2, and also question number 6.